Good morning, class. Today we're going to talk about two-part problems and some problems that take a little bit of extra work in solving when we're doing our physics. Now, before we get started, I want to take a little note. You might have found that on the worksheets, I might be providing some of the answers. When I do that, it's because I want you guys to actually show your work. In other words, I want you to show how you solve the problem. That's a big part of how you get marks. Anyway, let's move on. Sometimes we're going to have problems that have more than one step, and it's going to take our reading skills to determine when this occurs. So there are some simple steps that'll help us keep it going. That'll also help us organize how we think. Step one, make sure you read the problem and fully read the problem. Just skimming means you might miss certain information. Highlight the numbers that you find in the problem. These are the variables. These are going to be what you are looking for and what you're using. Also, make sure you know what it is you're looking for at the end. Sort the problem into its parts. I usually use short sentences or just little descriptors of saying when which piece is happening. And it helps me organize my thinking. And then lastly, that's when you take your steps to solve. So let's jump right into an example and see what this might look like. Well, let's do step one. Let's read the problem. Jeff is driving from his home in New Westminster to Chilliwack. He drives 50 kilometers per hour for 1 hour, then gets onto the highway and drives 90 kilometers per hour for 1.5 hours. How far did Jeff drive? So now we've read the problem. We think we might know what's going on. Let's highlight the variables or the numbers we find. 50 kilometers per hour for 1 hour. And then there's the second one, 90 kilometers per hour for 1.5 hours. And then we ask our questions, how far did Jeff drive? Now, when we have to sort our problem into parts, there are two parts that hopefully are pretty obvious for you. There is one section where he's driving 50 kilometers per hour, or in other words, that's city driving. And then there's the other section where he's driving 90 kilometers per hour, or highway driving. Now, the question of how far Jeff drove isn't one or the other, it's actually both. So the total distance is going to be a combo of the distance that Jeff goes in the city and the distance that Jeff goes on the highway. And that's hopefully something that you understand. You're like, oh yeah, I totally can figure that out on my own. So we're going to have to do this in multiple steps. First, how far did Jeff go in the city? Well, looking at our formulas, the one that is going to help us find how far is the distance version. Its distance is equal to the velocity multiplied by the time. Now we have the velocity here, and we have the time here. He drove 50 kilometers per hour in the city for 1 hour. So I'd say he drove 50 kilometers per hour multiplied by 1 hour. I take a look. Are my time units matching? Hours and hours? They are. That's good. Okay. So I can go ahead and do this multiplication. 50 times 1 is 50. And what units do I have left? Take a look here. We have kilometers. So we drove 50 kilometers. So that is our city driving amount. I get to put that in right there. How about my highway driving amount? Again, I'm looking for how far, so I get to use the same formula, velocity times time, and how fast you're going, 90 kilometers per hour, and how much time does it take, 1.5. So 90 kilometers per hour multiplied by 1.5, 1.5 hours. Again, check your units. Hours, hours, they match, so things are good there. Now 90 times 1.5, we can punch that into our calculators. That should be 135 kilometers. And that's our total distance that we go on the highway, 135. And we can take this and put it in right there. It looks like we're going to get 50 plus 135. So the grand total, the total amount that he drove was 185 kilometers. Jeff drove 185 kilometers. There we go. Now, hopefully you found this to be a very easy introduction to two-part problems. And I tried to choose a problem that wasn't too complicated, but as you see, you definitely have to do it in two parts. There's no way to do this with one simple formula. Where it can get challenging is when you have to find the average velocity when there are multiple parts. To find that average velocity of the whole movement, you can't just take the two velocities and average them out. That won't end up working. What you have to do is you have to find the total distance and divide by the total time. That's how you determine your average velocity. So let's take a look at John, who's biking up this hill. He is going 3 meters per second, and it takes 2 minutes to get to the top. Then it goes down the other side, and it happens in 15 seconds. What was John's average velocity? So I'm going to highlight our information again. 3 meters per second, 2 minutes to the top, and then 15 meters per second for 15 seconds, and we want to know what his average velocity here is. If we just took the average between 3 and 15, that wouldn't work because John was going 3 meters per second for quite a bit longer. So there are two portions to this problem, pretty easy here. It's when he's going uphill and then when he's going downhill. Now, to find our average velocity, we see our formula needs the total displacement over the total time. The total displacement, we have no displacement values. We have no distance values. So we're going to need to use our formulas to calculate those. So in my uphill portion, I can find exactly how far did he go. So that'll be the velocity traveled multiplied by the time. Velocity and time here, and if I plug this in, 3 meters per second multiplied by 2 minutes, and I take a look at my units, seconds and minutes, oh no, that doesn't match. We can't do this multiplication. We need to make this match. The best bet would probably be to turn those 2 minutes into seconds. Now I know that there are 60 seconds in a minute, so if I did 2 times 60, that'd be 120 seconds. Now my units match. Now that's good, so I can go ahead and do that multiplication. 3 times 120 is going to be 360 meters. Now when he's going downhill, we get to use our same formula, velocity times time. It's going 15 meters per second and is going for 15 seconds. Let's take a look. Do our units match? Seconds, seconds. They do match, huzzah! And so we get to punch that into our calculators. 15 times 15 is going to be 225 meters. Now, we're not actually done the problem, and we can't just add them together. We see our formula up here at the top says that average velocity is the total displacement over the total time. So if I want to find my average velocity, I've got to take my displacement from going uphill and add it to the displacement going downhill. And in my time portion, I'm going to need to add my time going uphill plus my time going downhill. I'm going to use the seconds because I want to stay consistent with my units. So it looks like we're going to have to take 585 meters divided by 135 seconds. Punching that into your calculator should get you 4.3 recurring, so I'm just going to round it to 4.3, and the units here are meters per second. It looks like John's average velocity is 4.3 meters per second. Hopefully this was understandable for you. Please definitely give the problems a try, and always remember to show how you solve something, because that's the most important part of this chapter. Have a good day.